Yeah, very good morning, everyone. Selva here. Welcome you all to this event AskSelva 009 on Power System Studies. It's an interesting day, 4th April 2021. Exactly an year back, 4th April 2020, we have uploaded our first technical video on short circuit studies in YouTube. And that's the first technical video which we have posted. Thanks for all your support for the past 1 year to make this group much more useful and probably the knowledge which we have exchanged. I am grateful for all of you, each and every one of you, for enhancing us on a daily basis. Thank you so much. If you are able to see my screen and if you are able to hear my voice loud and clear, can you just type out loud and clear in the chat box so that I can move forward? If you are able to see my screen and if you are able to hear me properly, shall I get a feedback in the chat box that you are able to hear me properly? All good. So let's move on. So this is what we have for the our organization power projects. Thank you so much for 5,230 followers in YouTube, 14,235 LinkedIn followers, 1,234 Facebook likes, 254 Google reviews, and 128 Instagram followers. So thank you so much for all your love, and probably means we will definitely try our level best to add value to you so that you can gain or learn something, so that the time which you are spending with our YouTube channel is worth, or the time which you are spending on our LinkedIn article is worth. Right? Shall I expect at least one or two people to say like you are able to hear me properly? I am not really getting any feedback. All good. So today we are going to this. What we are going to see is this. We are going to see power system studies. We are going to see power system simulation softwares, different softwares, and we are also going to look at like why load flow analysis, why short circuits, and probably at the end of the session I am going to come up and trying to add few tips in ETAP so that how quickly you can use this software ETAP, and probably that reduces your time when you're working in this projects. So that's what I'm going to see. So let's straight away jump to this topic, power system studies. I guess like most of you have seen this image. If you not, no worries, like I will show that image. We are going to break the power system studies to different kind, and then probably means what say break even to what are the simulation softwares that could be helpful for that. And means what say today we are going to focus not all the studies but only specific to load flow and short circuit, and upcoming weeks we will try to cover different things. And at the end of the day I will share that means what's a mind map as well, so that you can just watch at your free time, and probably if you want to feel that to be enhanced, I'm happy to enhance. So that's what the topic what we have today. So today I'm going to come up with an ETAP simulation software maybe at the end of the session, and before that, like let's have some basic theory of what is power system studies. So can you type out like means what you know about power system studies in the chat box, or what are things which you know as a power system studies? I'm going to cover one by one, but still I expect the engagement in the chat box. So let me go to that here. I guess you're able to see the screen, right? This is a Mindmeister, like I have something also GIT Mind. So these are all probably the new techniques which has been used by few peoples on means what say better engagement compared to these slides and PPTs, right? Power system studies majorly classified like means what say steady state analysis and the transient, right? That probably means what say everyone knows it. You have a different simulation software for steady state analysis like ETAP, Dixieland Power Factory, PSSE, right? And transients again that can be further classified into I mean so to say electromechanical transients, electromagnetic transients, and probably if you take the same simulation softwares like ETAP, Dixieland Power Factory, PSSE, This could be used for all these applications like steady state as well as means what's electromechanical transients. But when it comes to the electromagnetic transients, we need to go for a PSCAD and EMT-PRV. So we will deep dive into each and every study and look at like what are the studies and what's the purpose of it. And we also discuss like is it the only softwares like ETAP, Excellent Power Factory, PSSC, are this the only softwares? Not really. There are plenty of simulation softwares available. So if you know any other simulation softwares, type out the other simulation softwares which you are using for a power system studies in the chat box. I will probably add few more simulation softwares after seeing all your comments in the chat box, right? So let move on to steady state analysis. So these are all probably a different steady state analysis which we perform for a power system studies, which could be like load flow, short circuit, harmonics, relay coordination, arc flash. So these are all the studies which are steady state. Few people may think that the short circuit is it not a transient. No, so means what's a short circuit study which we are doing basically in ETAP or Dick Silent Power Factory or PSSC is basically to identify the uh, short time rating of the equipments, which mean we are not really doing a transient short circuit. You can perform the transient short circuit itself, then that becomes a transient study, not really a short circuit study. If you want to find out the switchgear ratings, if you want to find out the short time rating of the equipments, so if you want to find out the braking, making and DC braking capability of the circuit breakers, then what's the study which you are performing a short circuit where you are trying to find out symmetrical current, asymmetrical current, DC current, etc. So all this comes under short circuit study, which is a steady state analysis, which is not a dynamic study or a transient study, right? So these are all the different means what's a studies which you can make a note like in a steady state, low flow, short circuit, harmonics, relay coordination, arc flash. Few people tend to add earthing also. If you means what's allowed to add that, I don't have any hesitation to add it, right? But it depends on the countries and depends on other stuffs. Yep, good. So, I mean, so say any other study which you feel something to be added into the steady state analysis, please use the chat box and type out if there is any study to be added into this if you want to watch. Right. So then probably one more thing which I am talking like means what's the ETAP, Dixieland Power Factory and PSSC are the simulation softwares which are generally used. But apart from that, there could be a plenty of simulation softwares which can be used. So if you have any other simulations which any other softwares which probably means you feel it is means what's the used, can we have some simulation softwares on this portion, right? I mean, so to say, any softwares which you feel like I mean, so to say, which could be used for a steady state analysis. Shall I expect something in the chat box? I'm not really seeing anything in the chat box. Might be because of the YouTube, I mean, policy. I guess they will allow only the peoples those who have a channels to type out the chat box. But probably means what's the next time you ensure that the chat is enabled for you. So I'm not really seeing any chats in the chat box. All good. So here itself, let me add maybe few more simulation software, and probably means I will align and I will share the link so that this link you will be also able to open it on your laptops or mobiles and you can see it. So it's not really means what is the softwares. Let me cut the softwares and probably means what say bring it here and probably name it so that you can understand like what are the simulation softwares which are available. ETAP, that's one, right? ETAP, Dixile and Power Factory, PSSC, right? Any other softwares? So I will just reduce the size so that means it's yeah. Any other simulation softwares which you are aware? Neplon, SKM, Sine, yep. EAPSM, yep. So there are plenty of simulation softwares. I will also share the link of all the simulation software. There are at least about 50 commercially available power system simulation softwares are there in the market. but probably means what say among them like ETAP, Dixieland Power Factory, PSSC are means what say predominantly used. And yes, region to region, probably there are other simulation softwares are popular like Powerwall somebody uses. Yes, I'm not denying it, right? So probably if you know any softwares, probably means at least add it in the comment after this YouTube video, that we will try to add this and we will send a consolidated list to all the people those who are watching, or we will add it as a post in our YouTube channel. Good. So steady state, which we are clear about. Then it comes to the transients. There are two kind of transients. One is electromechanical transients. Other one is electromagnetic transients. Electromechanical transients, you have different studies, like how you have seen steady state. There are different kind of studies like load flow, short circuit, harmonics, relay coordination, arc flash, earthing. Similarly, electromechanical transients has its own different kind of studies like angular stability. That's where you find out critical clearing time, critical clearing angle, all the stuffs. Voltage stability, motor starting, grid islanding, load setting. Right, spelling is a mistake here. I will correct that. Right. So electromechanical transients include all the studies, and means you can use the same simulation softwares which you are using for a steady state also for this electromechanical transients. You name any other simulation softwares as well, like Neplon or SKM or SIME or EAPSM. You use any simulation software, like there are, as I told, there are plenty of simulation softwares. Don't worry if I have missed softwares like Powervolt or EC Power. There are plenty of softwares, right? So this softwares probably means what say used for both steady state as well as electromechanical transients. But when it comes to the electromagnetic transients, I mean, so what say you need to predominantly depend on only these two simulation softwares. One is PSCAD, other one is CMTPRB, right? So if you talk about electromagnetic transients, then you can have I mean, so it's a variety of studies: temporary over voltage, slow front over voltage, fast front over voltage, that's lightning. Here slow front over voltage is the switching. Very fast front over voltage, especially for a gas insulated substations. Transient recovery voltage, ferro resonance, transformer or reactor energizations, or even sometimes line energization. Few people cover this as a part of switching over voltage, that is SFO, but means what's the you may treat that as a separate study as well. So these are all the means what say different studies which we can perform, and probably this is what we are going to see in the upcoming weeks as well. And questions specific to this, I guess in the description of this YouTube video, we have added the link for you to post the questions. You can post the questions. That questions will be answered along with this. There was an interesting question about synchronous condenser, so we will take up that question next week along with some simulations in both the ETAP as well as the Dixieland. Right. Good. So let's move forward to today's topic: load flow and short circuit. Why do we need to perform a load flow? Probably most of the times we do a load flow analysis and probably clicking the button and successfully the load flow converges, we think that the load flow is great. But the main purpose of load flow is not that. Load flow basically optimizes many parameters. Take an example: what's the on-load tap changer range which is needed, which can be defined only in the load flow analysis. What's the minimum tap, what's the maximum tap, what's the tap step, all these things has to be identified using a load flow. If you're selecting a transformer impedance as say example 8% or 9%, what's the voltage drop, what's the losses, whether it's okay or not for the voltage regulations, all these things has to be identified in load flow. Combined with load flow, short circuit and motor starting, you can identify the transformer impedance or you can optimize the transformer impedance. The transformer impedance what you have selected should not have a large voltage drops and heavy losses during a load flow or during normal operating conditions. At the same time, this should ensure that the short circuit current is well within the limit for the LV side of the switch gear of the transformer. So why we are doing a power system studies? To optimize the parameter rather than justify the parameter. I mean, what say, most of the time we are doing to justify the parameters what has been selected is right or wrong, but ideally load flow analysis has to be done at very early stage to identify the optimal parameters of the power system, so that losses could be reduced, voltage drop could be reduced, equipment cost could be reduced, quality could be improved, efficiency could be improved, and so on and so forth. Let's move on to a load flow and like break out of, what are the points, and upcoming weeks I'm going to come up with one by one small simulation examples to justify these parameters, but at least this week we will touch the study basics and what are the objectives of load flow, or what are the outcomes of load flow, or why do we need to perform load flow. Yes, so here you go. If I look at the load flow, load flow is like, what say, you can find out the power flow. What I mean by that, the equipment loading in each and every branch. That could be a transformer, that could be a cable, that could be a transmission line, everything. It could be, what say, identified using this load flow analysis, and this helps to find out the available transfer capability or available transfer capacity, right? So it is just not means finding out the power flow. It decides what should be the equipment rating, correct? It decides what's the equipment rating. That basically decides the continuous rating of the cables, continuous rating of the transformer, continuous rating of the switch gears, bus bars, you name it, anything. So this also means what say indirectly helps to identify one more parameter, that is ATC, available transfer capacity, which could be used for probably transmission planning and other stuffs, right? So uh, if your loading is less, that's not really necessarily has to be great. Sometimes this loading of the transformer or loading of the cable or loading of the 400 kV transmission network, if it is less, which means that network is not effectively utilized. So basically the objective of performing a load flow analysis is to ensure whether the equipments are optimally loaded rather than means was lightly loaded, right? So then it identifies the voltage at all buses. We need to ensure the voltage at all the buses in the power systems are within the tolerance limit, maybe plus or minus 5, plus or minus 6, plus or minus 10, depends upon the country, depends upon the voltage level, depends upon the equipments which are connected. If the voltage goes beyond this tolerance, this has always a problem. Like increase in voltage damages the insulation, decrease in voltage increases the current and hence increase the losses, increase the voltage drop, and probably increase the temperature. In turn it has again the impact on the insulation. So we need to maintain the voltage within the limit. In order to ensure the voltage at various buses across the power system is maintained within the specified tolerance, we need to perform load flow. If it is not maintained, then probably we need to identify some other suitable mechanisms to regulate the voltage, or probably to bring back this voltage within the rated allowed tolerance of this system. An example, you can use on-load tap changer, or you can use shunt reactors, so that you can consume reactive power so that the over voltage during Ferranti effect in a long transmission line is reduced, or kind of using other devices to regulate the voltage like SVC or a STATCOM. All these things to be identified here. So it helps you to identify the losses, what's the total losses in the system, as well as losses in each and every branch. When we say this, another interesting fact also has to be noted. This gives the losses for various possible operating configurations, so that it helps the operator to identify the most feasible or most economical or most optimal operating scenarios. When you have a very large interconnected systems, there could be an infinite possible configurations which might be possible. So for a different configurations, what's the losses for each different configurations can be identified using load flow analysis, right? So when it comes to the on-load tap changer, if the grid voltage fluctuation is known, and if load fluctuation is also known, then you can easily find out what's the OLTC range which you can need to regulate this voltage. I guess like I used to refer this article quite a lot of times. Dr. K.R. Rajamani, his monograph, talks beautifully about the OLTC range for a generating plant. I guess like let me try it. It has I guess he has it in his own profile as well. I'll just quickly check that whether I have it in my local. If it, I will open that and I will show you. But OLTC range, there is a beautiful article by Dr. K. Rajamani in his KR monograph, or even that article is available separately also, where he has demonstrated why the OLTC range is really important. OLTC range is really important for the generating step-up transformers, because it is just not to regulate the voltage, but also it should have the capability to extract the all or complete reactive power capability of the generators. Let me quickly find it. Yes, I guess this is this latest KR monograph. And probably means what you can do, you can probably reach out his profile and you can download it from link, or probably we will add this link also where to download this article of Dr. K Rajamani in our YouTube description itself after this class. So it's a beautiful article which I always recommend, and when I have started at the beginning, like I have always used this article to enrich my knowledge, right? So here is effect of tap changing on the reactive power flow. He has given different 7 cases. You can very well go and you can see this article, and the same thing can be simulated using ETAP. Like he has described 7 cases. So here, like an infinite bus, this is a source, this is a generator step up transformer, and it is I mean, so it's a generating substation, right? So looking at all, then probably means how this varies. He has adjusted the field current, and hence the reactive power injected will change. Like he has considered the 100 megawatt as a typical example, but you can play with the numbers in ETAP. That's always an advantage, right? You can see this is means what, say, no reactive power exchange. This is you are injecting reactive power to the system. This you are drawing the reactive power from the systems, right? Look at this comparison quickly. You can understand, even if the grid voltage is maintained 1 per unit, the change in the reactive power has a huge impact on the generator terminal voltage, and it has a small impact, or probably not really small, it's a considerable impact on the generating substation. Hope this is clear. The remote end or infinite bus, what we are assuming, like this has to be assumed like this: a 100 megawatt thermal plant or gas based plant, and probably means 125 MVA step up transformer, assuming that it is generating at 11 kV or 15.575 kV, which is stepping up to like 110 kV or 220 kV. And there is a transmission line, maybe single circuit or a double circuit, probably means long transmission line, and here it has been assumed as an infinite grid with 1 per unit voltage. If the reactive power is 0 here, with that, like means we'll say the voltage, if it is 1 per unit, here the voltage is slightly one higher, that is 1.003 per unit. Whereas if you are means what, say, forcing the field current to increase, what it will do, it will inject reactive power. When you are injecting 100 megawatt, if you are injecting 46 MVR, what happens, the voltage at generator terminal has increased from 1 per unit to 1.07 per unit, that is 107.4 percentage. And if you have gone through any data sheet of the generators, you can easily understand the generator voltage tolerance is only plus or minus 5%. Generator voltage tolerance is only plus or minus 5%, which means this voltage range is not really allowed. You are not allowed to inject this much reactive power to bring the voltage beyond 1.05 per unit or 105 percentage, because typically the tolerance of the voltage on the generator is very stringent, that's only plus or minus 5%. And probably means if you look at this, here the voltage has increased by 7.4%, but this place, like the voltage has increased about like 3 percentage or 2.7 percentage compared to this. On the other side, when you are drawing, just you have reduced the field current, right? IF is the field current. You are drawing 55 MVR. Look at the voltage. There is a drastic reduction in the voltage, 0.893. That means the voltage goes below 90%, 89.3%. And as again to stress, like the voltage tolerance allowed for the generator is only plus or minus 5%. So this reduction in voltage here not only impacting at this place, but also here you can see the voltage drops to 96.4 percentage at this place. So same thing which can be simulated using ETAP. Like I will come on the next week to I mean sort of showcase what's the impact of it and how do we mean sort of manage the same thing, or probably how to simulate the same thing in ETAP. In the meantime, like I expect you to simulate the same thing in ETAP, and probably means what, say, tag us in LinkedIn and post it so that we can review and I mean what, say, or help you in enhancing this. But this is an ideal article which you need to go through, and probably he has I mean so say gone probably depth as well. to like AVR manual, AVR auto, probably means was with the adjusting something, and having an on-load tap changer here. You can understand this means what's the tap at OLTC, right? Even with the means what's say consuming reactive power, your voltage could be higher, right? Means even with the increasing means was injecting reactive power, your voltage is slightly less. So probably means was with an OLTC you can have an advantage of extracting the complete reactive power capability of the generator, that is especially needed in present scenario where the reactive power support can be an ancillary service, where you can make the money from the reactive power support alone. Without means also supplying real power, you can support only reactive power and you can get a money in the ancillary service market. So in order to extract the complete reactive power capability of the generator, this OLTC range which is selected is extremely important. All good, I guess. Like I'm always a good to interact, but unfortunately for whatever may be the reason, I could see there are 25-26 audience those who are watching, but you might not be able to access the chat box. I will look at what's the problem, right? Good. Coming back to this topic, right? So OLTC range is not really important only for a distribution transformers where you are stepping down to feed the loads, where you can just take consider only the grid voltage fluctuation and the load fluctuation, and you can easily identify what's the OLTC range. But alternate option which I have shown from this KR monograph document is probably giving a new dimension of how to select this OLTC range for generator step-up transformers. Right, effect of tap changing on reactive power flow, that's the second topic in this KR monograph. I will add the link where to download this book in the YouTube description after the session. You can download this, and this is a nice article to go through. Good. So let me move on. So we have seen in a load flow why we are performing a load flow. One is like find out the reactive power flow, that helps you to identify the continuous rating of the equipment, that helps you to find out the ATC for the long transmission lines. It helps you to identify the voltage at different buses so that you know where you stand, and it helps also to understand what's the voltage control mechanism which you need to regulate the voltage. It gives you the losses in each and every branch as well as the total losses. It helps you to identify what's the OLTC range needed. And comes to another interesting fact, like a reactive power compensation or power factor correction. Yes, this is another good topic. I guess I need not really go into this. Probably means also you can go to our YouTube channel, and we have done beautifully two interesting videos on this, right? So if you do not know our YouTube page, just landed by means of click some link somewhere. Like this is our YouTube link, and probably we have done beautiful two videos on power factor correction part 1 and power factor correction part 2. You can watch this and you can understand what's the significance of power factor correction part 1 and part 2. After this video, probably exactly in a year back, you can understand about 11 months back, February means April last year we have done means also multiple power factor corrections and reactive power compensation studies for metros, for renewable power plants, both static and dynamic compensations. I guess like more or less each and every point what we are doing in the project we have revealed in this video itself. You can very well watch this power factor correction part 1 and part 2 video, which I am not really going to depth on this. As I told, like exactly this short circuit video which we have posted on 4/4/2020, and today means what say that video is about an year old exactly. And this is also another interesting video, Indian grid stability, which we have done on 5th April 2020 on the light of event, right? We have added means what say the description and the report, many things to that. You can always watch that reports. That's a beautiful report from Posako, talks about this same thing which we have done on the just before that event has happened on that same day, just exactly a year back. Let me come back. So reactive power compensation and power factor correction, which I am not really going to touch, but power factor correction is what we have talked about in that video. But if you look at reactive power compensation with respect to the inductive reactive power compensation for a very long transmission lines, you can always look at what's the length of the line, how accurately you are modeling it. Because I have seen quite a lot of solar plants which are feeding this 400 kV grid, which are connected with maybe 1 kilometer or 2 kilometer cables, which injects a huge reactive power, and always they are not able to meet the reactive power requirements of the grid. What I mean by that, when you are connecting a solar plant, you need to maintain some reactive power range or power factor, or probably you need to control the reactive power or the power factor, which they are not able to meet because of the just a small length of 1 or 2 kilometers. And means what say, approximately if you have means what say, 4 or 5 kilometer cables, it injects a huge reactive power in the 400 kV. So that probably you need to make a note of it. We have done quite a lot of assessments on various reactive power compensation studies, especially for a solar plants where the penalty is extremely high. And the other point, probably means most of the time this point has been means was stressed less. Load flow analysis gives just not the voltage at each and every buses, it also gives the angle at each and every buses. From there you will be able to identify the steady state stability of the system. If the angle between the sending end and receiving end are means what say wide apart, then probably the system is weak or the power flow in the transmission line is heavy. You that may decide like whether you need to go for a series compensation like fixed series compensation or a dynamic series compensation like TCSC, right? So there are quite a lot of articles which are available when to go for a fixed series compensation, when to go for a biased control series compensation, how to relate the steady state stability with that. I'll also add that links in the YouTube description which you can watch, and probably means in the upcoming weeks we'll simulate something and we'll just demonstrate like how the steady state stability works. Cool. So generator terminal voltage, this is another important aspect. I guess like the same article from KR monograph helps to understand a bit more on that. But this actually another important aspect of generator terminal voltage is how your generator terminal voltage has to be maintained by your cogeneration plant when it is operating with the grid. If you have a grid and if you have a local consumption, in addition to that, if you have uh, a generator which is a cogeneration plant, how do you manage or how do you control this generator terminal voltage to achieve the multiple objectives like regulating the voltage at its terminal, at the same time maintaining the power factor at point of coupling, minimizing the demand charges at the point of coupling. That's an art, like means we will see that also as a part of few simulations in the upcoming weeks. So that comes to an end of load flow theoretical portion. Load flow probably helps you to identify the power flow in each branch, so that the equipment loading, so that you can decide the continuous rating of the equipment and available transfer capacity of transmission lines. It identifies the voltage profile at all buses, so that you can find out where is the under voltage, where is an over voltage, and probably you can take a suitable mechanism to regulate the voltage. Losses, it gives you the losses in each and every branch as well as the total losses in the system. And you can understand like what's the OLTC range which is needed. As I suggested, there is an article which you can go through. We also talked about power factor corrections and reactive power compensation. As I suggest, like power factor correction, I strongly recommend you to watch this means both the videos on power factor correction part 1 and power factor correction part 2, which helps you to better understand what is power factor. Steady state stability, whenever the power flow in the branch increases, the angle separation between the two branches will increase, and that results in means what say unstable situation in the steady state itself. It is not really a transient unstable, it is a steady state unstable. We will see more on the simulations in the upcoming weeks, where we need to use a fixed series compensation or where do we need to use a dynamic series compensation. All these things with respect to the stability we will see. Generator terminal voltage, one is for generating plants, other one is for a cogeneration plant, and it is extremely critical for a cogeneration plant where you need to maintain the generator terminal voltage as well as maintain the power factor at the point of coupling, and of course with an objective to minimize the demand charges. So all these things how to achieve is an art that we will see in the upcoming sessions with some simulations. Cool. So let's go to short circuit. How this load flow helped you to understand to identify the continuous rating of the equipments. Short circuit helps you to identify the short time rating of all equipments in the power systems. I mean, most of the time we have a common mindset of going with a short circuit study is intending only for the circuit breaker selection. Answer is no. Each and every equipments in the electrical power system has their short time rating. What I mean by that, if you take a cable, if you take a transmission line, if you take a transformer, if you take bus, if you take CT, any equipments if you take in the power systems, everyone they have their own sort time ratings, right? If you take a switch gear, that could be rated for 1 second or 3 seconds. If you take a transformer have a capability to withstand the through fault current for 2 seconds. If you take a cable, there is a formula which has been used, right? The minimum conductor size which is needed, or cross sectional area of the minimum cross sectional area of the conductor A is given by the short circuit current into square root of T, that is a time, divided by K, that's a constant, depends upon the type of cable. So it helps you to identify, like, means if you want to means what say the cable to withstand the short circuit of 40 kA for 1 second, then you can easily find out what's the minimum cross sectional area which is needed. So each and every equipment in the electrical power systems has their short time ratings. How the load flow helps you to find out the continuous rating. Similarly, short circuit helps you to find out the short time rating of each and every equipment in the power systems. The short circuit helps you to find out braking, making and DC braking capability of the interrupting devices. This is probably critical. Probably when we run a short circuit study, most of the times people go only with the braking current, right? They will run a short circuit, the fault current is 37 kiloamps, okay, select 40 kiloamps breaker. That's not really true always. You need to independently review braking, making and DC braking capability. I guess, like, we need not say, there is a beautiful other video which is available in our YouTube channel itself. We have written article also on this, right, on the Tech Thursday. So means this is a beautiful article to go through. Means you not only article, this YouTube video also you can watch, which is worth watching. Just go through this video, you will get the complete dimension of the short circuit, at least at the preliminary level, at least at the preliminary level, right? So here, like LinkedIn, we used to write this Tech Thursday article and probably we have missed it couple of weeks, but now we are back. You can understand Tech Thursday is also ninth, and means today AskSelva is also ninth. We decided now to ensure, like, every day we are repeating the same thing for continuous basis on Thursday, on Tech Thursday article, right? This is how to limit this short circuit. And probably means, for say, previous week we have written something on the significance of X by R ratio of the transformers, right? So continuously follow us on the LinkedIn for tech updates, and probably means we are planning to go for a blogs as well in our website. If you are willing, probably means, for say, you can very well contribute as well, right? So thanks for, I mean, for say, spreading across like 11,000 peoples when we put up an article. Probably means, for say, the previous one goes to around 6,000 peoples. So thank you so much for watching. Continuously watch, but probably means if you feel some questions, clarifications, feel free to add it as in the comment. So we always welcome you, all your comments, and we will try to enhance our articles, means to extent possible from our end. Good. So this is another interesting update. Like, a short circuit is just not for the current. There is a possibility of a rise in voltage as well. Means it may be surprising for most of you, like, why there is an increase in voltage during a short circuit, but this is quite common when it comes to the single line to ground faults in ungrounded systems or resistance grounded systems or resistance grounded systems. You can very well, I mean, what to say, go and simulate a single line to ground fault, and that's also covered as a part of our YouTube video which I have shown. You can find out there is a rise in voltage during a single line to ground fault in ungrounded systems. And the short circuit study also provides inputs to many other studies like relay coordination, arc flash, harmonics, even to an extent motor starting, transient stability, because the impedance can be identified, or the source impedance can be identified only from the short circuit study. That's the update from me today on the low flow and short circuit. Let me come back to this agenda, what we have seen today. Yep, power system studies, we have gone, means what say, all the studies, and we have understood, like, steady state, transient we have seen electromechanical, electromagnetic. Let me probably come back here, right? Yep. So if we look back, power system studies, steady state, transient. In steady state, like, we have seen different studies, right? Low flow, short circuit, harmonics, relay coordination, arc flash, everything. And transient, as we have seen, which can be classified majorly into electromechanical transients and electromagnetic transients. And electromechanical transients, you have options, and probably means, what say, electromagnetic also we have many things which we have seen. don't worry about this link will be shared in our description of YouTube, which you can, I mean, so to say, just watch, and you can, means do like whatever I want, I mean whatever I'm doing now, the same thing which you can watch also. All good. So that we have seen power system simulation softwares, we are not really, I mean, what to say, seen so far. Means what to say, we have seen only ETAP, Excel, and PSSE, and some softwares which I have written here, but that's not really a complete list. I will give you the complete list of simulation softwares, but it's not really, means what to say, much impact. Probably means if you know like what's the software which you're using, that is more than sufficient. But it's always good to understand what all other simulation softwares are available. Like India, I mean, we have a software called MyPower, so that you may have. If you want, I can add that as well, right? Yeah, I guess like I have not added Power Volt, so you can keep adding it. I mean, so say there are many softwares like Easy Power, right? Even few simulation softwares are free, which you can watch it. I will share the list of complete commercially available simulation softwares as well as the free softwares which you can use it in the description, and we will discuss more on that in the upcoming weeks. We have seen why load flow, at least the theoretical part. We have seen why short circuit, again at least the theoretical part. We are probably, means for say, taking this one simulation at a time on a daily basis on the upcoming weeks. And probably whatever the questions which you are posting, I guess there is a link which is there in the Google form. Again, it is added in the description where you can post the questions. We will take up the questions also in alternate weeks. Like next week, there is an interesting question: how the synchronous condenser enhances the stability of the systems, or how it contributes to the short circuit. So we will discuss something kind of stuff like that in also in parallel. And this is like a subject matter expert, only one ask expert which we have done. That's going to continue. We will bring a few more experts, at least one in a month. That's what we have planned. And interesting fact is like preview sessions for IPSA Advanced Industrial Power System Analysis Unit Protection and Protection course which we have planned. That will happen on Fridays and Sundays. That's free, and that's where we cover, means was in detail like what we do as a part of different courses on industrial power system analysis or advanced industrial power system analysis or unit protection course or protection course. And advanced industrial power system analysis we are starting from May 2021, and we have now learning management systems, a beautiful learning management system which we are setting up. It is not completely ready now, may take a couple of months to come up, but means what say, all our courses and the video recordings are available for our means what say, students on this learning management systems, where you can learn and you can practice, you can submit the assignments, you can interact with your tutors, right, in addition to the live classes. Yes, AskSelva is continuing. The Thursday means we are started updating in Facebook and Insta as well. Those who are not joined in a Telegram group, you can find out again in the our description. You can find out this link which is there in my slide. You can also find out the same thing in our description of this YouTube video. You can join the Telegram group for all the updates. Good. So I thought of always ending up the session with just adding it values to the participants on some tip on simulation tool. Today, let's end up with the two tips on ETAP, and we will wind up our session today. Good. So one tip, like means when you are working on a very large project, when you are working on a very large projects, means what say, if you want to count the total number of circuit breakers or the relays, etc., you need not really count it manually. There is an option in ETAP where you can easily count it, right? So I mean, so say I'm going here, and probably means for say now it is everything is nothing, because like means for say there are no equipments which I have put up. If I'm putting a first bus, probably you can find like the bus is 1, and right, if I'm putting a second bus, you can see the number of buses has been increased to 2. This maybe looks very simple in a small projects, but when you're doing like 1,000 buses or 1,500 buses, it's quite really needed, quite it's mandatory. And this also helps you to identify how quickly you have to increase your number of buses, right? We have only 2,000 buses. If you're working on a project which has reached like say 1,800 buses, and if you need to model few more switch gears, then probably you need to take a call whether you need, I mean, so say increase or enhance your license or not. and this helps you to identify the number of relay, circuit breakers, all these equipments. Like if I'm putting a circuit breaker, yeah, that will increase the count in the circuit breaker HV. So where to go for this? If you close this is probably means for the system manager. Like you will typically in the single line diagram, this will not be there, correct? You have to go to the system manager, and probably means for say if you have to go to like means for say distribution components, right? You can see this multiple things, right? One line components, distribution components, multi-dimensional database rules, etc. So means what say you need to go with the means what say components, one line components, and you can find it there. And one drawback of here is like means was say now I am deleting this bus, still this bus number is 2, that means it's showing 2 buses. So means in order to means if you want to get the right quantity of the elements which are there in this single line diagram, then you need to always keep this dumpster empty. It is counting bus 2 because bus 1 is here and bus 2 is in dumpster. Now when you delete, it goes to dumpster, which you may aware, like bus 1, bus 2 is also showing, but the bus 2 is in dumpster, right? So you have to be a bit careful when you are counting it. You ensure that you are keeping dumpster empty, or when you are deleting it, you delete it from you delete it. Just use a shift delete, right? If you use shift delete, that will not go to dumpster. That will be means permanently deleted. Otherwise, means what to say? Yeah, here you can see it is only one because I have used shift delete now. I guess this helps you to identify like totally how many equipments are there connected, etc. Right? Means what see, whenever I'm putting elements, you can understand the numbers are means what say increasing here, right? Like generator synchronous generator 1. Now if say example if I pick multiple, you can understand the numbers are whenever I'm putting here, probably you can look at this numbers are increasing, right? So that's the first tip which I thought of sharing. Second one, I'm not really sure how many of you are aware of this. Means what say if I give this means what say check circuit continuity, right? This check circuit continuity, all the equipments will get go to a different mode, right? So whether it is in a option called tools options, go to ETAP projects. Let me repeat from where I came. Tools options, ETAP projects, voltage source as a swing source, that might be either false or true. Voltage control source as a swing source, which is true or false, right? Like if I am making it a false, then look at what happens, right? All this your generators, those who are operating in a voltage control mode, becomes dull. That means that's not really energized. So that means it's not really allowing, or it's not really taking the voltage control bus as a swing source. It remains as a voltage control source. Only when you're changing it to swing control, this will be enabled. Otherwise, all these things which are in voltage control are disabled. So that's the last tip, and we will discuss more on to this in the upcoming weeks. Thank you so much for joining. And if you are means what say not really part of the Telegram group, please join using our Telegram group for all our updates on any trainings related to power system protection, power system analysis, renewables, microgrids, battery energy storage systems. Join this Telegram group to even clarify your doubts, questions. Follow us on Tech Thursday. Follow up on AskSelva, and we are planning to come up with like giving a tip on simulation tools on every Monday. If let's see whether we will be able to start it by tomorrow, because we have made quite a lot of promise and we are not able to fulfill. So let me keep it with me, and we'll ensure that we will try to do our best. Thank you so much for joining. Have a great day. And if you are not means what's really following us on LinkedIn, YouTube, Facebook, Instagram, means if you want to follow, the link is again there in the chat box, means description of the same video what you are watching, and follow it up. With that, I am signing off. Selva here. Have a lovely Sunday. Thank you so much.